Hi all, I've got the wastegate thing sorted now on my car. It's as normal with everything on the car, it's kind of two steps forward and one back. So now I've got the turbo controlling quite well, but when it's set at the moment to 0.8 of a bar, it's an absolute animal really. I took it out for a little tryout on the road yesterday. Albeit a cold day. The roads were dry, but it was cold. Went along the motorway at 50 miles an hour, fifth gear, floored it, and as soon as I got anywhere near the boost, about 5,500 RPM, so we were about 70 miles an hour then, it spun the rear wheels up, which obviously is not really desirable. So what I've been looking for is a boost controller that's can set the boost per gear, or failing that even by speed. So then I can set less boost in the lower gears, and maybe even have less boost when it's sort of on the road and cold and wet, as opposed to track day tyres on. So I went on eBay, which is my normal sort of port of call for looking at stuff to see what the options are, because even if I don't buy from there, obviously so much is listed on there, you can get a fairly quick feel for what's out there. And there doesn't seem to be much that can change boost levels automatically. There's quite a few that say they got high or low boost, but that involves pressing a button, which I'm not really wanting to do when I'm driving. Select third and press a button for high boost. And so we go right up this price range, and then we get to these e-boost ones, which I thought was going to do the job, because they say they do 6 boost levels and you can set boost per gear. So when I was looking the other day, there was one up for sale second hand, albeit in Australia, but it was 180 quid delivered. So I thought, bargain, I'll have one of those. So I've done my normal ADHD thing and ordered it up, and after ordering it, read up about it. And it can boost per gear, but it's not taking any input from the engine to know, or the speed to know what gear it's in. Basically, you have to set micro switches up on the gear lever to change it up and down through the boost range. Now I'm kind of thinking that sort of thing's not going to be very reliable, and it only has to miss once or twice, and then in say second gear, instead of having second gears low boost, you got sixth gears high boost. To my mind, it's just too unpredictable. And that's the sort of 500 quid ones. And then after that's kind of it. So, as I possibly mentioned before, I'm an electronic engineer, so I thought, well, is this a little project I can think about? The great things with running a Hayabusa engine, this is a little diagram, is you have a sensor on the gearbox to tell you what gear you're in. On mine, it doesn't actually seem to be working. Well, I suppose it feeds the ECU for something. But basically, you can see I've calculated the figures here. So these numbers here are, so when it's in first, it's 1.8 volts, 2.3. So you've got a nice easy feed there to be able to tell some electronics what gear you're in, rather than risking this this micro switch thing, which it just seems a liability to me. So it then comes to the, well, what do I do then? How do I control this? Could I buy a boost controller that's like the switchable, two-stage switchable one, and somehow use that to kind of clag a bit of extra electronics onto it to switch between boost levels? And that was a possibility. I had thought about that. I've actually got one here that I bought, very cheap one off eBay, and butchered it to see if that was possible, and it didn't seem to be. It packed in quite quickly when I was kind of bench testing it, so I gave up on that idea. So that option seemed to fail. So next thing was me thinking, well, someone must have already thought about this and designed something, because I think most motorbikes have this gear sensor thing. I don't know about car engines, but so of course we go on good old YouTube, search on DIY electronic boost control, and fail to really find anything. There's some very good information, don't get me wrong, you know, about solenoids and background information, about how how boost controllers work. I mean, one of them detailed the frequency that you've got to send to the solenoid, which is about 30 hertz. That means it switches on and off about 30 times a second, which was handy, because I would have guessed it being quite a bit lower than that for the solenoid. So there was information there that would help point me in the right direction, but it was all pointing me in the direction of having to design this myself. Basically, to control the solenoid, you need to send it a signal that is called PWM, which means pulse width modulation. I'm not going to go into depth about the electronics and all this sort of stuff on here. What I'll try and do is remember to put some links in to, say, Wikipedia or something, so if it is something you're interested in learning about, you can do, because it's far more than I can sort of quickly explain here. And if you're into electronics and that, you know what PWM means anyway. So yeah, so the solenoid, you need to give a signal. So you can see my note here. You need to give it a signal of about 30 hertz. That means it's switching on and off 30 times a second. And to control the time it's on and off, it's a PWM signal. So I had a little search online, and found there's a very, very simple IC called a 555, which is just used for all sorts of stuff. It's such a simple little thing. They're like a couple of quid, I think. And I found this circuit that said it's a PWM output. You put a clock in there, so that controls the frequency of the output, so I can use another 555 wired up as a monostable, which outputs a regular pulse at 30 hertz or thereabouts. And then here, modulation input, it changes the pulse width depending on the voltage that's put into it. And as I've got a gear change sensor that tells me, or gear position sensor that outputs a voltage depending on gears, and I want to change the PWM on gears, well, it looks like a no-brainer to me. So here is prototype circuit number one. We have the two 555 chips there, one as literally a clock, sending a clock signal out, and one as our pulse width modulation. We have a little pot there, a little potentiometer, a variable resistor that's pretending to be my Hayabusa gear thing, and then just got a little power transistor there that can up the power for the solenoid, because the solenoid needs a good few watts, and obviously these little chips kind of supply down in the milliwatts. And there we have it. So playing around with this, I can change the time that the solenoid is open depending on the input voltage. All good so far. So obviously I can't stick this thing on the car, so the next stage is going to be making what's called a strip board or breadboard PCB layout for this to give it a go. After having a little dig around in drawers looking for strip board, which is this stuff you kind of use for prototyping, I found these. I'd completely forgotten for a project I was looking at before. I had some little pre-made 555 A-stable circuit boards. So I've just put the right components in now for 20, well, about 30 hertz. That the LED's flashing is coming out odd on the video because obviously it's flashing much faster in real life. Anyway, so I put the components in and I got a nice clean about 28 hertz out of that, which is what I want for my clock driver. I'm now going to see if I can fudge one of these circuit boards to be the PWM one as well, because it's kind of easier doing it that way than using the breadboard. In case there is any electronic geeky type people watching, that's obviously the little circuit board, and I got one of those oscilloscopes that turns my PC into an oscilloscope, so that's the output from there. Where are we looking along here? It's saying it's on 28 hertz, which is just about perfect. So that will be my clock feeding the second circuit, which I haven't started making yet. So I'm using this one as my clock pulse. That's just like a standard little, I think I get these PCBs for about £1 off of eBay. This one I'm using for the pulse wave width modulation. So as you can probably see on here, and if I flip that over, it's had a bit of modification, but it's probably better than using breadboard. And I've got a little resistor here pretending to be the gears. So when we have a little look at the oscilloscope here, the red line is the voltage off of what's pretending to be the gears, and the blue line is the output that will be opening and shutting a solenoid. In first gear it's 1.8 volts, so it's basically that's pretending to be in first gear. So as we go up the gears, oh, let's go the right way. If we go up the gears, you can see so we're on about 2.2 volts there, which is second. You can see we'll be energizing the solenoid longer. So if we go all the way up to about 3.7 volts, which is about fourth gear, you can see as we're slowly going up, so that's about fourth gear there. You can see there the pulse is high for longer, so that means the solenoid will be open for longer, which means we will supply more kind of boosted air, if you like. So more high pressure air that's come out the turbo will go onto the top of the wastegate, which will then kind of assist the spring to keep the spring shut longer. What I haven't figured out yet is, obviously I need to do trial and error to find out how much assistance the air gives. I don't really know at the moment is what range, because it's called the time up to time down is called, here you can see duty cycle is in a percentage. So that there is about 30%, so it's high for about 30% of the time. So what I don't know is how much of the time we need the solenoid open, how much effect that will have. It seems I've asked on a couple of forums, there's a couple of quite good Facebook forums for Hayabusa turbos and turbo bikes, but nobody's really been able to give me an answer, because it seems to be so dependent on not only the base spring you're using, but also the wastegate you're using, the turbo you're using. It just seems to be too many variables. It does seem to be something I'm going to just have to experiment with, which is slightly worrying, because I'm not sure if I can experiment with this on the road, because obviously if I give it too much boost, especially as we're in the autumn at the moment, and could spin up the back so violently, I could end up in a bit of a bother, but let's see. Hi, thanks for getting to the end of the video. If you're not already subscribed, please do so now. Just hit the subscribe button and then hit the bell button, and that way YouTube will tell you when there's any new videos. We've got some big plans ahead for the channel, including possibly a car build from scratch. So if you want to get involved with that, now's the time to subscribe. Cheers then, bye.